Hi guys, this is Gopika here, and in today's video I'll be discussing the practice set 1.2 of the chapter similarity. Okay, so it has 11 problems in it, I think, and the first 5 problems I'll be discussing in this video and the rest in the next. Okay, so I hope you have watched the previous videos because all those concepts we'll be using here. Okay, so without wasting time, let's get started. Okay, so this is the first question in the practice set 1.2. Given below are some triangles and lengths of line segments. Identify which figures ray PM is the bisector of angle QPR. Okay, so clearly we are going to use the angle bisector theorem and its converse over here. Okay, basically the converse of it we'll be using. So let's check the first sub question. So here we have PQ is 7, PR is 3, MR is 1.5 and MQ is 3.5. So first we check the ratios. MQ upon MR is equal to 3.5 upon 1.5 and this is same as 35 upon 15. Okay, I have shifted the decimal once, or I have multiplied by 10 on numerator as well as denominator. So that will be 35 upon 15. Again, if I divide by 5, then 7 by 3. Okay. 1 second. Yeah, here you go. So 35 divided by 5 is 7 and 15 divided by 5 is 3. That is 7 by 3. And this is same as PQ upon PR. Therefore, this ray PM is dividing the opposite side MQ upon MR in same ratio as PQ upon PR. That means by converse of angle bisector theorem, PM bisects the angle QPR. Simple, just cross check that if the ratios are equal and then come up with the conclusion. If the ratios are not equal, then ray PM does not bisect. Okay, so let's check sub question 2. Here PR is 7, PQ is 10, MQ is 8 and MR is 6. Okay, MQ upon MR is equal to 8 upon 6. Dividing by 2 on both numerator as well as denominator, we get 4 by 3. This is a reduced form. I can't reduce it any further. Similarly, PQ upon PR is 10 by 7. Again, this is the reduced form. So 4 by 3 is not equal to 10 by 7. Hence, MQ upon MR is not equal to PQ upon PR. So here, ray PM not bisect angle QPR. Okay, so let's take the third sub question. Yes, so this is the third sub question. Here PQ is 9, PR is 10, MQ is 3.6 and MR is 4. So let's check what is MQ upon MR. MQ upon MR is same as 3.6 upon 4. So this is same as 0.9 because 4 9s are 36, but however we have a decimal point. So first we will have to write 0 point and then we can consider 36 and then 9. So that is 0.9 and PQ upon PR is 9 by 10. Again it is 0.9. So here also the ratios are matching. That means MQ upon MR is equal to PQ upon PR. Therefore, by converse of angle bisector theorem, we can say that PM bisects angle QPR. Okay, since the ratios match, that is, this ray is dividing the opposite side in the ratio of the other two sides of the triangle. That means the ray is bisector of the angle P. That is what converse of angle bisector theorem says. Okay, simple. So let's move on to the second question. So this is the second main question. In triangle PQR, PM is 15, PQ is 25, PR is 20, NR is 8. Okay, they have given 4 measurements. State whether line NM is parallel to side RQ. So here we have to state if NM is parallel to RQ. So by the diagram and the thing what we want to prove, it is obvious that we are going to use the basic proportionality theorem. Actually converse of it. Okay, so first we need some values for it. Now here they have given value of PR to be 20 and value of NR to be 8. So PR is 20, NR is 8, then PN will be PR minus NR, that is 12. Okay, similarly MQ will be PQ minus PM. PQ is 25, PM is 15, so MQ is 10. Now we need these individual values because we need to check the ratio. What basic proportionality theorem says, or what converse of it says, if Pn upon Nr is equal to Pm upon Mq, then Nm is parallel to Rq. That is what our converse of basic proportionality theorem says. So we check that ratios. Pn upon Nr is equal to 12 by 8 and dividing by 4, we get 3 by 2. If you divide by 4, numerator as well as denominator. Similarly, Pm upon Mq is equal to 15 upon 10. So here we are dividing by 5. Numerator, if you divide by 5, it is 3, and 10, if you divide by 5, it is 2. So 3 by 2. Now these two ratios are matching. That means Pn upon Nr is equal to Pm upon Mq. By converse of basic proportionality theorem, we can say segment Nm is parallel to side Rq. Okay. So Nm is parallel, that we had to state whether it is parallel, and then we have to give reason. So reason we have already given, that is converse of basic proportionality theorem, and we have justified the reason by showing that the ratios match, and then the sum is complete. Actually, it's very simple, right? So looking at the diagram and looking at the question, we can easily make out which theorem or which or converse of which theorem we are going to apply. Okay, just by mere observation. So let's see the question number 3. Yes, so again I think we have the angle bisector theorem. Whenever you can see an angle bisector involved, mostly we are going to use it in the solution. Now in triangle MNP, NQ is bisector of angle N. So NQ is bisector of the angle N. MN is 5, PN is 7, MQ is 2.5, and we have to find QP. Simple. By angle bisector theorem, we have that NM upon NP is equal to QM upon QP, because the bisector divides the opposite side as in same ratio of the other two sides of the triangle. Okay, so NM upon NP is equal to QM upon QP. So 5 by 7 is equal to 2.5 upon QP. Now I cross multiply, or rather multiply the denominator towards the other side. That is 5 into QP is equal to 7.7 into 2.5. Hence QP is equal to 7 into 2.5 upon 5. Now if I divide 2.5 by 5, I end up at 0.5, and 7 into 0.5 is 3.5. Therefore, QP is equal to 3.5 units. Since the unit is not given, we can say just 3.5 units. Okay. Simple. So just by using the angle bisector theorem, we had proved, or we have not proved, we have the value of this segment, that is QP. Simple. So let's check the next problem. Okay, so this is the fourth problem. Actually, I forgot to mention the number over here, but this is the fourth problem in your practice at 1.2. Okay. Measures of some angles in the figure are given. Prove that AP upon PB is equal to AQ upon QC. Okay. So if you see the figure, they have given APQ is equal to 60 degree and PBC is equal to 60 degree. So these two angles they have given, and we have to prove that AP upon PB same as AQ upon QC. That is AP upon PB is equal to AQ upon QC. Now here we can use the basic proportionality theorem. But for using basic proportionality theorem to prove this ratio, we need to prove that PQ is parallel to BC. And for that, this information we have to use. The angles. Okay, so let's check how. Angle APQ is equal to angle PBQ is equal to 60 degree. Okay, so if you observe, they are corresponding angles. Okay, one below the other, they are corresponding angles and they match. So by corresponding angle test, we can say PQ is parallel to BC. Okay, so we have two corresponding angles and the values are of both the angles are same. That means by corresponding angle test, PQ should be parallel to BC. Once PQ is parallel to BC, then directly we can apply the basic proportionality theorem, and by basic proportionality theorem, AP upon PB is equal to AQ upon QC. Simple. So remembering this part, or being able to remember the corresponding angle test is important over here. So we have I think 3 tests to identify the parallel lines. One is the alternate angles test, one is corresponding angle test, and the other one is interior angle test. Okay, if the interior angles are supplementary, that means their summation is 180 degree, then we can say the lines are parallel. And if the alternate angles are equal, then the lines are parallel. Alternate angle means the Z angles. Okay, some similar to Z, we can they will appear alternate angles. Okay, Z pattern actually, and if they match, then the lines are parallel, and if corresponding angles match, then also the lines are parallel. All right, so using those tests, this actually you might have learned in standard 9th. Okay, the chapter regarding parallel lines and transversals. Okay, I think in the very beginning you might have learned. So there they have discussed the 3 tests in detail. So by that, we can say that PQ is parallel to BC, and then simply applying the basic proportionality theorem, we end up at U. Okay, simple. So let's move on to the next problem. Okay, so this is the question number 5 of practice at 1.2. In trapezium ABCD, so ABCD, side AB is parallel to side PQ is parallel to side DC. So now in this particular trapezium, AB is parallel to PQ, PQ is parallel to DC. So other way around, we have 3 parallel lines, AB, PQ and DC. Okay, AP is 15, AP is 15, PD is 12, QC is 14. We need to find BQ. Okay, now if you observe, as I said, AB, PQ, DC are 3 parallel segments. Okay, and AD and BC are transversals. So if these 3 are parallel lines, obviously AD and BC are 2 transversals. Therefore, by property of ratio of intercepts made by 3 parallel lines and their transversals, we know that the ratios match. When you have 3 parallel lines and 2 transversal, the intercepts they make are in same ratio. So AP upon PD is equal to BQ upon QC. Okay, we have discussed the proof also in previous video. Alright. So AP upon PD is equal to BQ upon QC. AP is 15, PD is 12, BQ is what we have to find, and QC is 14. Okay, now I divide the denominators to the other side, multiply the denominators to the other side, that is 15 into 14 is equal to BQ into 12. That means BQ is 15 into 14 upon 12. Now I divide 15 and 12 by 3, then 5, and here 4 remains. So 5 into 14 upon 4. Again I divide 4 and 14 by 2. So 4, here 2 remains in the denominator and 7 remains in the numerator. So 5 into 7 upon 2, that is 35 upon 2, that is equal to 17.5. Okay, this calculation part I think you should do by yourself. It's very simple. What we need help, what you might need help is which theorem or which converse part we are going to use in the sum as a reason for our ratios. Okay, so rest calculation part you should do by yourself and just check the final answer. So BQ is 17.5. Okay, simple. So I think in this 5 sums, the first 5 sums itself, we used all those theorems at least once. The parallel lines property we used, the angle bisector property we used, BPT we used, that is basic proportionality theorem, converse also we used. So now the rest part, that is 6 to 11, question number 6 to question number 11, I'll discuss in the next video. Okay, so stay tuned guys, and thank you for listening to me guys. If you like the video, please share it with your friends, and if you're new to the channel, please subscribe the channel and do follow us on Instagram as well. And please write in the comment section for any doubts and queries. You can also ask your doubts through Instagram. We will post the answers as soon as possible. Okay, so thanks guys, take care.